I've had a few requests from my students about working with inequalities, so I'll go through a few examples here. We have this one here, we need to solve it. That means we need to find an inequality expressed in terms of y. Now 3y add 1 is bounded by two inequalities, so it is greater than 7 and less than or equal to 13. So first of all, we want to get rid of the constant with 3y, and then finally we'll divide by 3 to have y on its own. So first we would add -1 to both sides of the, or to both ends of the inequality here. So we have 7 minus 1 is less than 3y is less than or equal to 13 minus 1, and this evaluates to 6 is less than 3y less than or equal to 12. And to get y, we must divide by 3 throughout, so this becomes 2 is less than y is less than or equal to 4. So this inequality here has been solved, or the solution of values y greater than 2 but less than or equal to 4, and equal, sorry, to 4. Here's another one to try here. We need to find an inequality in terms of p. We divide throughout by p as by 3 to get 1 is less than or equal to p less than 5. What about this one? We want to solve for m. First we'll get rid of the -6 by adding 6 to both ends of this inequality. So we have 9 add 6 less than or equal to 3m is less than 15 add 6. It's 15 is less than or equal to 3m less than 21. And then we'll divide by a 3 throughout to express this, or these two inequalities in terms of m. 5. And that's our solution, m being greater than or equal to 5, and m being less than 7. Next we have the inequality 20 is in 8x minus 4 is less than 28. We'll add 4 to each end of this expression, so we have 20 add 4 is less than 8x is less than 32, and divide throughout by 8. So this is 24, so we'll have 3 is less than x is less than 4. And that's our inequality. That's it. Thanks for watching the video. My name is Alistair. Any questions or comments, please send them to me. Please like, follow, or subscribe for more videos like this. Bye for now. We need to find the range of values that satisfy this quadratic inequality. If you clear the brackets, you would have a quadratic function. So let's call that function f of x. And so we can actually sketch a little graph of f of x. Now the zeros in this function will be at 3. Let's make this no longer. Will be at, let's say here is 3 and 5. When I say zeros, I mean where the graph cuts the x-axis. So we know it's quadratic, so it must have, and its x squared will be positive. So we know it must have a shape similar to this. So the range of values that satisfy this is indicating that as a function f of x, which is y, the y values, they must be less than 0. And from this graph, the values less than 0 lie below the x-axis. So we can see that our values must be greater than 3 but less than 5. So we have our values x must be less than 5 but greater than 3. So this is the range of values that satisfies this inequality. Here's the next inequality. So we have f of x now is x add 1, x minus 2. Our zeros of this function will be at -1 and also at 2. So we have -1 here. And we have this as 2. Again, the coefficient of x squared is positive, so we will have this U shape. And we're looking for positive values of f of x, or y values, so it must be greater than 0. So any value less than -1 or greater than 2. So our two values is x less than -1 and the other x greater than 2. So the range of values will be x less than -1 and x greater than 2 to satisfy this inequality. So let f of x be 3 minus 2x, x add 5. If we look at this, our coefficient of x is negative, so we expect our curve to be the opposite if it was positive. We'll come to that in a minute. But let's find the zeros. We know that we will have a 0 at -5. And the next 0 would be at 3/2. So one 0 at -5 and the other at 3/2. We sketch our graph. -3/2, let's call it about that. And -5, let's call it, let's make it there. So again, our graph this time will have a different shape because it's the coefficient of x squared will be, or is, negative. So you'll have this downward shape. We're looking for positive values, so they must lie between -5 and 3/2. So anything greater than -5 less than 3/2. You can verify that this quadratic will have a negative coefficient of x squared by clearing the brackets. And these are the two zeros. That's where the graph cuts the x-axis. My name is Alistair, thanks for watching this video. Any questions or comments are welcome. Please like, and please do follow or subscribe for more videos like this. Thanks and bye for now. We have an inequality here and the task is to solve it and display it on a number line. As we look at this, we can see that we have actually two inequalities, and the first is 5 less than 3x at 2, and the other is 3x at 2 is less than or equal to 17. So we'll do this one first and then this, then we'll write our final inequality and then draw it on the number line. So here we have 5 take away 2 is less than 3x. So we have 1 is less than x, which means x is greater than 1. And on this side we have 3x, this is 17 take away 2, which is less than or equal to 15. So we handle these just like equations, just that we pay attention to the positive. If you divide or multiply by a negative number, then you change the sign of the inequality. Otherwise, it's treated similarly to equations. So we have here x is less than or equal to 5. So our inequality that we have is x less than or equal to 5 less than 1. So this has been reduced to x greater than 1, x less than or equal to 5. And on the number line, we just draw a little sketch of it here. 1, 2, 3, 4, 5. We have a solid, and this one is open, and this line is thickened across here. So x greater than 1, we're not including 1, so we have an open circle, but it must be less than or equal to 5, so we are including 5, so we have a closed circle. Here's our next inequality. Again, we have 3 less than or equal to 2x add 5, and the other inequality is 2x add 5 is less than 7. Now we simplify this, we add -5 to both sides, will this give us negative 2 is less than or equal to 2x. So we have that x is greater than or equal to negative 1. And on this side we have 2x, we have 7 take away 5, which gives us 2. So you have x is less than 1. So this inequality has been reduced to x less than 1, x greater than or equal to negative 1. Clear this up. Negative 1. Oops. And on the number line, let's call this 0, 1, 2, negative 1, negative 2, negative 3, and so on. So we have x greater than negative 1, greater than or equal to negative 1, so we include this. And our line will be going this way, but it must be less than 1. So it does not include 1. So this is an open circle, this one is closed. And that's your solution. This inequality reduced to this, displayed on the number line as shown. And this is our final inequality that we'll be looking at today. We have two inequalities. We have less than 8x minus 4, and the other is 8x minus 4 is less than 20. Rearranging this becomes positive 4 if we've been on this side, so we have 16 is less than 8x, which means x is greater than 2. And here we have 8x, this becomes a positive 4 if you move it on to the right hand side, so 8x is less than 24, so x must be less than 3. So this inequality has been reduced to x less than 3, x greater than 2, which is this inequality. On the number line, it's 1, we do not include 2, so it's an open circle, and also we do not include 3, so it's just the values between 2 and 3, excluding 2 and 3. Thanks for watching this video. My name is Alistair. Any questions or comments are welcome. Please like, follow or subscribe for more videos like this. Thanks and bye for now. Hi, this is Harris Maths. Suppose you're given this inequality which represents the number of n CDs that were bought from, let's say, your favorite music store, and you're asked to rearrange this inequality to obtain n, which is the number of CDs, the maximum number of CDs that can be bought. Well, we proceed similarly to how we would tackle an equation. So we have 6.5n. First we'll add negative 4 to both sides. So this becomes add 4 minus 4 less than or equal to 1 minus 4. And the result is 6, which is less than or equal to 71. And n represents the number of CDs, the maximum number of CDs that can be bought. So we can find for n by dividing both sides by 6.5, get this less than or equal to 71 over 6.5. To get rid of our decimal, we can multiply the top and the bottom by 2. So we have n is less than or equal to 142 over 13. Now 142 divided by 13, 142 divided by 13 is approximately 10.9. So the maximum number of CDs that can be bought, maximum number of CDs that can be bought is 10. Thanks for watching this video. My name is Alistair. Please like, follow or subscribe for more videos like this. Bye for now.